We call this similarity, uh, image processing as DIP, that is digital image processing, which is not just limited to adjusting the spatial resolution of our day-to-day images that we go for capturing from our cameras, or nor only there are like we basically go for editing the images in our mobile phones, or we go for increasing the brightness, increasing the contrast, and trying to filtering all the things in the images. uh, Coming with the part of editing, normally we have a lot of tools in our mobile phones where we can use them, and we can edit either their we can edit all the different kind of things. We can change the resolution, we can resize it, um, we can adjust the contrast, brightness, cropping. All the things can be done in the editing part of a image. So what is the basic need of coming over here and learning it in the same way as we are doing it as well as in the tools itself? So over here, if we if we understand this one topic of electromagnetic spectrum, or where the particles are going to travel in the speed of light, where each particle will be containing bundle of energy, and that energy we go for calling it as photon. So when we calculate an image, the electromagnetic spectrums that are present in an image can be said as radio frequencies, microwave frequencies, infrared frequencies, as well as the human eye, which the human eye can see. That portion is called visible spectrum, where we will be seeing a VIBGYOR colors to be visible, and these VIBGYOR colors stands for violet, indigo, blue, green, orange, yellow, and red colors. And apart from this, we do have ultraviolet rays also, X-rays, as well as gamma rays also. But the human eye can only be able to see the VIBGYOR section, that is the visible section, that we are going to see the colors, we are going to see the contrast and all. That's it. But apart from this, a lot of things are going to be captured from the camera. That is the rest of the things like microwave, infrared, ultraviolet, X-ray, gamma rays, radio frequencies. So all these things will also be captured from our camera. So, but just the human is going to see the visible spectrum that a human eye cannot see beyond those sections. And for this, uh, we have to analyze the other stuffs also in spectrum. So to analyze all these things, um, we have to go for image processing, because a lot of applications or a lot of fields where we can use image processing section in different kind of fields, where a lot of things are being discovered nowadays just by using X-rays and gamma rays, UV rays, a lot of radio frequencies, ultraviolet. So all these spectrums can be analyzed in different streams of fields in the world right now. And those fields can be, first of all, we can use that in the medical field, and image sharpening, and a lot of fields are available. And here, something like if I'm talking about image sharpening and restoration, So in this field, in this field of technology, where images are used to, where it is an important part of the aspect, where we have to zoom, we have to blur, we have to sharpen, either grayscale to color conversion, detection, detecting edges and vice versa, image retrieval as well, and image recognition. So all these, I mean, uh, things we can do it by image processing. Suppose if there is some sort of, I guess maybe everyone are aware of, there is one of the um, um, latest technology that is uh, blooming in the, sorry, booming in the social media industry. Like, you can restore your old images. That is done by where there will be an image or a photograph which will be old from the 1980s, 1990s, where you can recreate your image pixels uh, in a modern way, where all the electromagnetic system, spectrums of the image can be retrieved by using this image processing, digital image processing method. And one more things, and many more things, something like if you are thinking of working on the medical field, then you may be aware of gamma ray imaging and PET scan, X-ray, X-rays that basically, if a human being is damaged with the bones and all, so we go for, doctors suggest us to take an X-ray to check out what are actually, what is actually happened to that bone, and medical CT scans, UV imaging. So UV imaging is one of the best thing that to understand the process. Something like, suppose the area of the whole Earth is scanned by a satellite or from a very high ground by using the satellites. So we can recapture the image. we can we can recapture the image, and from that image of the earth we can spectate the earthquakes that are, the cracks of the earth, i mean by detecting uh, the damages that has been occurred on the grounds. So due to even from those kind of images also, we can basically go for spectating the, and we can even allow the areas where more earthquakes are being occurred. We can take the satellite images and we can make a prediction saying that the earthquake can be happening in next few days or month or anything in of the future. So in this way we can do it for UV imaging also. And transmission and encoding of the images. So, this the first image that has been transmitted over the wire from the from London to New York via submarine cable, and that picture was uh, which took 3 hours to take from one place to another place. Now, just imagine that today we are able to see live video feed or live CCTV footage from one continent to another with just a delay of seconds. It means that a lot of work has been done in this field too. So this field does not only focus on transmission but also an encoding also. Many different formats are also have been developed, from high level to low level bandwidth, to encode the photos and then stream it over the internet or etc. And all those are different things. And as well as this image processing can also be worked on um machine robotic visions, where biggest challenges are to increase the vision of the robots, making him to see the things or identify the things or identify the object that is kept in front of him. So is we have to train that uh, robot with the machine, sorry, with the trained data, so that can be sent by using the images to the robots. And the uh, hurdle detection, or if we call this as a uh, line follower robot, where hurdles, or we can find out what is the object in front of the robot. This can also be used, this technology can also be used in um the latest cars that are going to be on an autopilot mode, so they can detect it, they can or auto drive the overall car itself, just by analyzing that the what is the object that is in front of them, whether they are car, whether they are some stands or different objects that they can recognize. So, for image processing can also be used for color processings, for adding or converting the color model into grayscale, grayscale into color model, and vice versa. Storing the images and encoding and decoding of the colored images and storing it, this can also be done. And as well as pattern recognition, we can do that uh, for our pattern recognition. I guess China or Japan, I don't remember the country's name, but they had built one of the project which was which was used to recognize the pattern that uh, he used to work on. Suppose if I'll say that I want to go from my home to bus stand, and from bus stand to railway station, and from railway station to again bus stand. So suppose if I send a robot from my home to uh, bus stand, there are many different ways that a robot can travel. I mean, there are many different routes from where my robot can travel. So it is going to check out, first of all, it is going to go through all the routes. It is going to go through all the routes, and I mean the basic version that they had created it is going to travel from all the routes, and it is going to estimate the time which is the shortest route. I mean shortest route. And from there, he used to go, and next time we don't have to tell uh, I mean, the robot that you have to go from this route itself. It will always take the shortest path, and it will reach the bus stand. And this kind of things um, can be done by using the pattern recognition system that we can write in our image processings. And next thing is video processing also can also be done. The Basically, what video is nothing but the frames of images that are available, and it will be played continuously. So that's why we call this as a video. But that is also a kind of image. We can also process, and we can make some sort of um things like video processing, uh, which is going to include something like noise reduction, detail enhancement, motion detection, frame rate conversion, aspect ratios. Then we have color space conversion. We can contrast it, and likewise, all the things can also be done in our video processing unit also. And this is just a simple demo, like where we can because many of us will be confused, like we don't know, I mean, the technology that we are learning, where we are going to work on, or where we are going to use this technology, because we have a lot of things filled up in our mind where we cannot define, like I mean, if someone, I guess someone had asked me the question regarding how we will come to know that um, like this technology, I mean, or this library or this open source framework should be used at this time itself. It depends upon the requirements. So if we come to know that, I mean, if we come to know that the technology that we are using is used in where, I mean, which fields, then it will make us much more easy to learn the to learn the new things. Okay, so this was all about a small introduction regarding image processing, and uh, we are going to now work on the real-time implementation of our image processing project, and we'll be working on the images, few of the images, and if possible, I can, sorry about this. Yeah. Okay, we'll just work on and we'll start our implementation of image processing. And in this, we will be using the libraries like NumPy, which is basically used for array manipulation, as well as linear algebra if I am trying to use Fourier transformation and random number capabilities. So at that time I'll be going for using NumPy. And pandas, anyhow we know about pandas, like for data manipulation and data analysis we go for using pandas. And CV2, the I mean uh, the previous project that we had worked on, face detection, we had used this CV2 library, which is used for computer vision task, something like calculating the images, fetching the images and all. So all these things can be done by CV2. And SK image. So SK image is one of the newest uh, I mean, uh, thing that you can see over here. This basically library is called as scikit image, and it is a collection of algorithms for image processing and computer visions. So over here, SK image, if you're trying to work on image processing, then SK, we call this as SK learn also, or scikit image also. So both the things are same itself. And if you're starting to make your career on image processing, then sklearn will be a piece of cake for you all. And this is about scikit image that we are using. And one more library that we'll be using will be pillow. Pillow is Python, that basically we call this as PIL, and PIL stands for Python Imaging Library, which is an open source library, and we can try to manipulate the images that we are trying to extract the um, resolutions, restoring or coloring it, or trying to display it in a WebGuire way. So at that time, PL can be the best option for us to use it. And the next thing, and one more library that we will be using will be Matplotlib, which is going to generate some histograms, figures, graphical user interface toolkits for us to be watched out, and it is going to help us. Okay, over here, we'll just import the libraries first. Import NumPy as NP and import pandas as PD and import CV2 as CV from and we'll be using some Google patches. Google dot collab dot patches import cv2 underscore. I am sure that we had used in our last example previous, and from sklearn, that is scikit-learn, uh scikit-learn scikit skimage skimage will be importing the IO input output, and PIL from PIL will be importing the image, and from matplotlib we'll be importing matplotlib dot pylab as PLT. So this is one of the all the libraries that we will be using, and I'll be working on these libraries itself. So first thing, we'll just execute this and check out whether all the libraries are available in our Google Colab. If not, we'll install our libraries. Okay, this is working fine for us, and there is no error that has been displayed. And one thing that we can do, like as we are working on image processing uh, method, so over here, let me just, either you can fetch it from your local machine. Suppose if I'll be working on few of the images, suppose if I'll be working on 3 images, okay. So these are the 3 images: 2.jpg, 3.jpg, 4.jpg, or you can do the things in this way also, where we can do something like we can go for taking out some sort of images, and for these images we can just right click on it, and we can say copy image address, and as well as we can use these images and work on the expected images that we are trying to work. Either we can use the images in this way also. I'll be showing both the ways, and before proceeding I want to import all the images that I have added, that is 2, 3 as well as 4, all the images within my code by using some URL patterns. I'll be saying URLs equal to, and I'll be adding it in an list. Okay, this will be the first one, first image, comma, second image, comma, third image. So all the images will be returned over here. And I want that all these images should be displayed. Something like, from here I can copy path and I can paste it, all the images, copy path, Control V, and as I already know the name of the image, so I'll take it over here 4. So this is the one way how we can add our images, or the second way that I had showed, we can right click on it and copy image address, and suppose if I'm trying to display that, Control V, I can display it in this way too. And after this, enter. And I'll be taking a loop where all the three images will be displayed uh, over the URLs loop. So I'll be taking for URL in URLs image equals to io dot image read, and this will be from the URL. What basically we are doing in this for loop is, sorry about this. Over here, the URL's content, I mean all the images, I'm trying to load it in the URL variable, and I'm trying to read all the images by using the image variable. Image, I'll be taking image 2 equals to cv dot cvt color of the image. I'm trying to change the color of the image from as well as image underscore 2. Okay, not image, will not take image anyhow because we are using image one only over here. So we'll say cv dot color. I want that this color should be, I mean the image color should be changed to something different kind of a color. I mean the first color, let me just show you the images. So this is the basic color. I mean it is something like this one. These are the basic colors of my image. This one. So the basic color of these images, I want to change it to something like BGR 2 RGB. So these are the colors: blue, green, red to red, green, blue. So we are saying to change the color now. Enter. So now I'll be taking the final frame. Final frame equals to cv dot h concat of the image as well as image 1. We'll mention this in the smaller brackets, as well as image underscore 2. So I want that both the images should be displayed in a single frame. I mean side by side itself. I mean I want that the first it should display the original image, and second the image that I have converted should be displayed. So this is cv2 underscore im show, which is going to display all the images final underscore frame, and I want that to print our images with /n. So let me just try to run and execute this one with, and over here in the below part we can see that we have changed our image color from blue to something else. I guess 2 dot, okay, let it be content /3 I have taken 3 images, but it is displaying 2 images itself. Let me just try to rerun this again. Okay, so I guess that is being displayed. I mean, this is at the above part of the screen over here. So this is being colored separately for the images, and in this way we'll be changing the colors. This is the original image and this is the blue colored kind of that way that we had added in our uh, images, and now we will be trying. So this is being done, and we can scroll the output and check out the different colors that has been added with the shadings. Once we change the color of the images, now we will try to add the image contours. Contours are basically the edging, I mean border, and the intensity and the color should be the same as it is for all the I mean images. If we can see over here, we can see the border has I mean corners, I mean the outline shaping of the images. So I am trying to do that, just trying to display the outlining shape. So for that we call that the name, particular name is contour, contours, contours. And this is going to allow us to frame the edges of the image with the same color as well as same intensity. Okay, so this is being done, and after this I'll be mentioning the code again. So first of all, let me just check out what are the type as well as shape, yeah, as well as width, height, and number of channels of the images. So before going to that, let me just print out what is the type of the image. Int image dot date type. I mean, we are checking what data type it is, whether this is being converted or not. Print, and this is for checking of the height of the image dot shape of 0. This is going to check the height, and if I say print image of 1, this is going to check out the width of the images, and at the last I'll be checking the number of channels of the image. Uh, that is can be done by shape dot shape of 2, indexing value 2, and I forgot the shape over here, dot shape, and run and check out. So this is going to give us the data type of our image, that it is of an integer value, and the height of the image is 667 pixels, and width is of 1000 pixels, and the number of channels that are present in the image is 3 numbers. And now we'll try to enhance something, like we'll be trying to generate histogram of color image as well as the grayscale images. Sometimes you want to enhance the contrast in your image or expand the contrast in a particular region while sacrificing the details in colors that don't vary much. A good tool to find interesting regions in the histogram is the histogram. To create a histogram of our image, as we have seen in the previous, I mean, examples also, like how we can create histogram and all. So we'll be using our matplot dot pylab hist function, and by using that we'll be allowing the histogram to check all the pixels in the colored image. And for that we'll be writing the code plt dot hist of image dot ravel is one of the function. And for this we'll be saying comma bins equal to 256 comma, and we'll be allowing the range equals to 0 comma 256. We are providing the range over here, and we'll say to display the histogram, that is plt dot show function, and execute the program. So this is the um, image, image histogram, where all the pixels of RGB channel, uh, we, we can see that all the things can be displayed directly over here. But suppose if you are trying to represent some white patches or trying to fetch out some green patches in our image, like this is something like where we cannot define or understand a proper way. But if you go for defining it in a proper histogramic way, or displaying the image in a proper, if you're trying to fetch the outlining of the image itself, then that will be the good thing for us to display all the changed colors, and we can display. And for this I'll be taking color equal to, and these colors will be uh, one will be blue, next will be green, and the third will be red. BGR, that is blue, green, and red colors. I'll be displaying different color formats, where blue line will be defining something, green color will be defining something, and red color will be defining something. And for I'll be mentioning it in this as for I of column in enumeration of color, creating one of the CV dot calculating our histogram with the image, comma I. This is basically going to define the separation of the colors, none, comma 256, 256, comma 0, comma 256 will be the coordinates, and enter plt dot plot. And with this we'll be trying, we are trying this because we are not understanding what actually the ranges and coordinates are, the ranges that are present in the image. And I want that the red, green, uh, and blue color should be divided separately, and it should display separate sections, where the red color is present, blue color is present, and green color is present. And for this plt dot plot, this histogram of color equal to columns, and plt dot limit of it 0 comma 256 will be the coordinates, and I want plt dot show function. I mean, this should display all the images, I mean, which are consisting of, I mean, the image portion where blue, green, and red colors are present. Basically, we go for checking out. If green is not visible, then we calculate for white color. And here we can see there are three different lines, red, green, and blue, which is saying this much of pattern of color is being mentioned in the images. And if I'll try to something like, if I'm trying to convert it and again check out whether the color pigmentation is being decreased or not. And for that, I'll say gray underscore gray image equals to cv dot cvt color of image, comma cv dot color, and this should be converting from bgr to gray, bgr to gray this time. And we are trying to convert the image of our cv dot I mean directly the image into gray color, and cv2 underscore I am show gray underscore image, the variable name. And we'll try to execute this one and check out whether we can see that the image has been converted into a grayscale directly. And now let us check out whether now let us check out whether the histogrammic way where the BGR color has been decreased or not. So for that, now we'll be checking that the frequency of the image has been decreased for one third, at least one third part of the histogram or not. For that, plt dot hist gray image underscore image dot ravel comma pins equals to 256, the coordinates, comma range equals to 0 comma 2 comma 256 coordinate. And if you try to check out plt dot show, and within this we'll refresh and check out whether it has been decreased or not. Okay, so here we can see there is some sort of difference between this image, I mean this histogram, as well as this histogram. This is of the same image, but there is some sort of increase in the contrast of the image. there is some part has been increased and some part has been decreased compared to this histogrammic of the original, and this is of the grayscale. So this means that it is being changed from I mean there is no blue color is present as we were displaying in the above section. You can see blue line is going up over here, and gray, there is no sort of red and green color to be displayed. So for that we can see it has been ranged and increased level of frequency in our histogram, and this grayscale has been increased its frequency now. Now I'll be trying to find out the image contours, and will be adding, as I have already said, that image contours are nothing but the edges which will be having the same color as well as the same intensity. The border will be having same color as well as the same intensity. And to add the contour, we must add plt dot. We'll be taking the contour of matplotlib, which is consisting of gray image, comma, origin equals to the image. Will be checking out the image from our contour as well as the image from our original image. Okay, we can see this image has been now contoured, and it will be displaying only the edges. That's it. I said that contour is basically used for displaying the edges of the images, and here the edges of the image has been displayed, where this is hand and this is he is holding some sort of device, and this is I think a river, and this is the mountains and all these has been given a proper border, and we can add this contouring thing of matplotlib. There are two different kind of contours we can add. We can add either matplotlib contours, or either we can use that using the OpenCV library also. We'll check out, this is one method how we can use matplotlib contour. And if we are trying to set the threshold for the contour detection, we can do that by using ret, thresh equals to cv dot threshold of gray image of gray image, comma 150, comma 255, comma 0. We have set the threshold to 150, 255, and as well as 0. And this is im2, comma contours, comma hierarchy, and this is one of the way how we can add the contours directly. cv dot find contours thresh, comma cv dot retr underscore tree. And this is one of the this is the syntax of how we are going to find out the um, contours. cv chain underscore approx, comma underscore simple, Okay, this is done. And now we'll try to draw CV dot draw contour in the image, comma, contours. We'll be drawing the contours now. -1, comma, 0, comma, 255, comma, 0, and comma, 3. And now plt dot show plt dot im show of image. And if you run this, oh, I guess there is an error where not enough values to unpack expected 3 got to. Okay. Hmm. IM2 contours hierarchy CV dot find contours CV. I guess CV unpack. We are trying to give IM2, that will be the image, and hierarchy. Expected 3 got to. Okay. And check out. Okay, so we got this successfully because I guess they have changed some sort of format in this, and over here we can see that the patterns and the contours are being displayed exactly that we were seeing in the image. Like we are trying to display the contours for the image, and now we will be uh, finding the proper grayscale by using
Hello,
the
sir.
grayscale.
Hello,
Yes, sir.
sir. There is a question in the chat box. Kusuma madam, she was asking like CV2 is a third-party module. How to install it?
CV2,
The-
if you are using it in the um, sorry, if you are using it in the local machine, then you can go for installing it by using pip install opencv python. You can install it by using over here, and the same way you can install it in the, I guess, let me just try to open a and new notebook so that we don't get any errors for this. And if you don't have anything, pip install open cv python, and if this is already installed, then I guess this will work fine. And you can see it is saying already satisfied, so we can directly work on this way also. Is it clear, Suma ma'am? If you are working it on the particular local machine, then in the same way we can go for installing it, as well as we can install it in the same way in Colab also. Okay then, so we have now transformed it in our contours to a proper display where the contours will be edged properly and it is being displayed. And now if we are trying to do some mathematical transformations of our existing grayscale image, then by using the histogrammic equalization. So we'll be using some histogrammic equalization as well as some grayscale transformation in this one, where it can be done by using IM2 equals to 255 minus gray underscore image and cv2 underscore imshow of im2. And if I try to execute this, then I should get the grayscale histogrammic equalization in this way, where this is actually displaying something like a format of X-rays. We call this as grayscale transformation. And if suppose I'm trying to do some one more transformation of the image after adding a constant, all the pixels should become brighter and a hazing like effect of the image should be generated. So if I try to add it something like im3 equals to, with the mathematical equation of 100.0 divided by 255, which is going to be into gray scale of the image, gray image plus 100. And now I'll be trying to add some more brightness and display this IM show of our IM3 and run this. Some more brightness to this one compared to the above image. Now, if I try to decrease the lightness level of this image, then we can calculate it by using same thing. I'll be taking one more variable im4 equal to 255.0 into grayscale gray image divided by 255.0 star star 2, we can say. And we can display it cv underscore i2 of im4, that is the variable. And here you can see the lightness is being displayed more, and over here we have decreased the lightness of the image. And likewise we can try some more mathematical operations also, but uh, we have to do some more equalization. And now in this part of the code, I'll try to add the histogrammic equalization, and this equalization will be done on the dark image. So basically this is going to transform the gray level histogram so that all the intensities are equally common and possible. So the transform function is a cumulative distribution function, that is CDF we are going to call, of the pixel values in the image, and this can be normalized by the mapping range of the pixels that we desired for the range. So before going to fetching the histogrammic I mean equalization, I'll be adding some one of the function that is saying diff hist equalization, which will be having im comma nbr underscore bins equal to 255, sorry, not 256, and will be making this as a function which will be consisting of histogram histogram equalization of a grayscale image, where this will be displayed on the I mean over there. I am histogram comma pins equals to, will be using our numpy np dot histogram where im dot flatten of null and nbr underscore bins comma with the coordinates of 0 comma 256, and we'll be having our cumulative distribution function which will be said as cdf equals to our im histogram dot cumsum function. So this cumulative distribution function that we have used, that is cumsum, and for this again we'll be adding cdf equal to imhist dot of max function, which is going to be multiplied with cdf and divided with cdf dot max, cdf dot max to normalize the things. And over here enter. Now we'll be adding a mask to it. cdf underscore mask equals to np dot np dot ma dot mask mask underscore equal underscore equal, which is going to be of the cdf comma 0. And once we add the mask to the image, next we'll be adding the same thing, cdf underscore mask equals to cdf of the older mask, the above mask, minus cdf dot mask dot minimum value, which will be with the integer multiplied with 255 divided with maximum value of the cdf. cdf underscore mask dot maximum value minus cdf underscore mask dot min function. So I have given here the masking values. Now, now I'll be adding the CDF equals to numpy dot ma dot filled out filled filling our CDF mask comma 0, and it will be as type with the uint, that is the image integer that we are having, that the image type is of uint, and this should return us the CDF of im dot as type of uint 8, I mean integer of 8. And after this we'll end the function over here, and now we'll apply the function on the dark image to increase the contrast, and we could observe that the contrast of the black background has increased. So we can do that. im5 equal to hist eq, that is equalization, im4, and cv2 imshow of im5. So over here the image that we have we have dark over here will be increasing the contrast of our dark image in the background. Run this. Invalid syntax, sorry. And we'll run this again. CDF mask uint numpy.nd array object has no attribute mask. nd. Okay, over here I have forgot CDF, and this should work fine. Again, one more error, that is numpy. Okay, some spelling typing mistakes. And we can now find out that the background image, you can see this image is some sort of, I mean, it doesn't have any contrast in the background, that is mountains and rivers that are being displayed. But in this image we have added some sort of contrast to the image in the background, and this is how we can add the image things. And some extra things, we'll try to visualize the histogram of the image after our histogram equalization has been done. I mean the thing that we have done now. We'll try to plt dot hist of im4 dot ravel comma bins equals to 256 with the range equals to with the range equals to 0 comma 256 and plt dot show function. And if we now find out, there might be some slight changes in our histogram. You can see some sort of uh, lines that are being coming with some distance. This is the changing thing that we have done in our image. And if I'll be trying to do the histogram for IM5 after histogram equalization, plt dot hist of IM5 image dot revel comma bins equal to the above thing that I had done was for, if I'll be telling you people, I had done it for IM4 variable, but now I am doing it for this one, this image, the contrasted image. The before one that I had done was for this image, and now I'll be doing the histogrammic equalization and trying to display a histogram for this image for IM5 with 256 comma ranging of range equals to 0 comma 256 and plt dot show of display. Now we can see a lot of difference compared to the dark image that we had turned it into grayscale, and now the thing that we had done, that is for the contrast that we have added, it is displaying some sort of very large distance between the uh, spectrum, the visible spectrum that we are using within the histogram. Now, if the last part of our program, the project, that is now we'll try to convert we'll add some sort of FFTs in our gray images, that is Fourier transformation. Basically, Fourier transformation is used to find the frequency domain of an image, and we'll see how we are trying to add these things just in a matter of time. We'll just finish off this one and we'll try to display some sort of bindings, and this will be im blur function equals to cv dot blur function, which will be consisting of gray underscore image comma 5 comma 5, and transforming the image to our frequency domain. We can do that by f equal to np dot fft dot fft2, that is im blur f shift equals to np dot fft dot fft shift of f, and magnitude underscore spectrum equals to 30 into np.log, and this will be done by np dot absolute of our f shift function. And we are trying to find out the frequency bringing from 0 to frequency component. And over here plt dot subplot of 1 to 1 comma plt dot imshow will be having imblur function comma cmap comma, sorry, the mapping will be fetching it with the gray color, plt dot title. I'm trying to give a title to it, and the title will be input image comma plt dot plt dot xtext xtext comma we'll just define it in a 0 of array comma plt dot ytext. And now we'll just define the same thing with the magnitude spectrum. Copy, Control V, subplot of 122, and I am sure, and I'll be taking magnitude spectrum over here and remove this I am blur with the gray thing, and the same thing for the title of our PLT function, and this will be saying magnitude spectrum, which will be having x ticks as well as y ticks, and plt dot show function, and we'll run this. And if we check out in the below, we have created two images. One is the input image, and the second image is this is being displayed for the magnitude spectrum. We can find out the exact spectrum for our the input image. So for the sinusoidal signal, if the amplitude is going to be very so fast, you can say it as a high frequency signal, and that is what we are displaying over here. And last thing, we'll just end it out on this note in just last steps that we are having, and we can end this and we can have a QA session. Now I am trying to display all the three formats. One format will be HPA format and the input image, as well as the format in the JET. So HPF is nothing but high passing frequencies. So we are trying to display that in our last thing. First of all, I'll be taking rows, comma calls equals to I am blur, comma, I am blur, not comma, dot shape, and I'll say crow, comma, c call equals to round of rows divided by 2, comma, round of calls divided by 2. And now we'll be removing all the low frequencies with rectangle size of 10. So I'll say F shift crow minus 10 is to crow plus 10, comma, cc call minus 10, then cc c call plus 10 equals to 0. So I have provided this f underscore I shift equals to np dot fft dot ifft fft shift of f shift, then img underscore back equals to np.fft.ifft2 of f underscore I shift. And again img underscore back np dot apps of image underscore back. The previous one we are trying to calculate this, and now we'll try to figure all the things. Fig size equals to, it should be of 20 comma 20. Will be displaying all the figures. plt dot subplot of 131 comma plt dot im show im blur, comma cmap of equals to gray. And the last thing, plt, wait a minute, I'll just copy it from above itself so that because it is taking a much time to type. Control V. So here we are saying we'll be having xtext as well as same thing. I'll be saying this as the module of, I'll copy both the lines and I'll just try to change. Control V, S subplot 132. I'll be giving plt show imb back, and this should be also of the gray, and input image over here I'll say image after hpf, and over here we'll be giving xtext and all these things and blur and everything. And the next thing, last part, 133, 32, 33 PLT show. I am back. PLT I am show over here will be displaying no gray things, but I'll be displaying img underscore back. G underscore back. And for this, I'll be setting this as results in JET and all the text and everything. PLT dot show. So I'm trying to take three figures. One figure will be displaying the image for our figure size of 2020, and second figure will be the image which will be displayed after high passing frequencies, and at the end we'll be displaying the results where JET will be displayed. And if I run this, so this is how our image can be displayed. This is the original input image, and this is the image after HPF, that is high frequency, and these are the results that are being displayed in our JET. So this is what the actual thing that we can do in all the image processing, where we, even though I haven't taken much more things in I mean, a lot of things should have been covered in this, but I couldn't complete it just due to the short amount of time. So this is the end of the project, where we'll be getting, where we'll be trying to display and fetch the different kind of histograms of the images with adding contrast, adding frequencies, and displaying the results in a very different way. So that's it from my end, and I guess the time is also up. I'll be sharing the files as well as the images, so you can all try it. And uh, yes, Guru Prasad sir. So
Uh,
I guess the time is end.
Hello.
Yeah, sir.
Yeah, sir. Any participants having the query, so they can just ask the sir.
I guess the time was very short, and we couldn't complete many more things that I wanted to cover. Hope so it will be done in the next time.
Yeah. So any participants, if you are having the query, you can unmute yourself and ask the Raheem sir directly the question. Even you can pass those questions to, I can call it as our mail ID. We will pass it to the sir.
Yeah, good morning, sir. Can you listen?
Yeah,
Yes,
madam.
sir, I am.
Yeah,
Yeah, ma'am, we are listening.
it will be great if you give few examples on MRI imaging or medical imaging upcoming.
Actually, in the upcoming sessions.
Yeah,
Okay, sure, ma'am. We are having a session, right, sir, on at 2 o'clock, I
yeah,
guess.
today.
Yeah, 2 o'clock today.
Okay, ma'am. We'll have a, session on this itself, and we'll see how we can use it. Can you just repeat your question, ma'am, once again?
Saying that some MRI images, if you take some,
MRI images.
yeah, yeah,
Okay, ma'am.
any
Okay, fine.
example will okay for us.
Yeah, yeah, sure, sure. MRI images.
Yes.
I'll just try to uh, take the session on MRI images itself, on the image processing.
Yeah, thank you, sir.
Thank you, ma'am. Thank you, ma'am.
Hello. Any participants for having the query? So I hope. So as we can find no queries from the participant end. So we will end up this particular I can tell session. So sir will be joining in the afternoon session at 2 o'clock once again. So if you are having the queries at that time also, you can ask the queries by listing it down. So with this note, I thank Abdul Rahim sir for giving his time. So we will conclude this session, and we will rejoin again at 11:30. The session will be carried out by one more eminent person, that is Dr. Archana Rajurker Madam, Professor and Head CSE Department, MGMCE Nanded, at 11:30. Please, all of you join on time. So thank you one and all for patience listening.
Thanks a lot, sir.
Yes, sir. Thank you, sir.
Difference. Those are called as keyframes are selected from the input video. Now in our research, keyframes are selected using the SURF algorithm. So what is SURF? SURF is a speeded up robust feature. This is descriptor. Okay, this is called as SURF descriptor, speeded up robust feature descriptor. Why it is robust? Because it is scale and rotation invariant. Though we rotate the image, though we scale the image, means we reduce the size or increase it or zoom it, still it doesn't have any difference. And that's why it's called as robust SURF descriptor. So the video sequence here in our approach is first divided into segment consisting of 20 frames. So one segment is generated from continuous 20 frames, okay, to find out the keyframes. The pixel-wise distance of the luminance component between the first and last frame, means first frame and 20th frames. Luminance component distance, pixel-wise distance is calculated for each segment. Now such 10 segments are generated, and for every 10 segments, they are grouped together to form a basic thresholding unit. For one segment of 20 frames, such 10 segments are grouped together to form a basic thresholding unit to find out is there any significant difference between the content of the frame. So all these segments within this unit share one threshold. So the segment whose distance value are less than the corresponding local threshold, they are classified as non-boundary segment. So hence, large percentage of redundant frames are removed. Whenever there is a repetition, those are not treated as a keyframe. Whenever there is a distance greater than local threshold, then only those frames are considered to be distinct or different frame. All other frames are the similar frames. Like this, we identify the keyframes. Now, for the key point, now SURF has got the important feature of finding out key points. So we are going to use these key points for finding out the difference between the keyframes. So SURF algorithm is based on sums of 2D Haar wavelet responses. SURF uses the Hessian matrix because of its good performance in computation, time and accuracy. So this SURF algorithm first computes the Haar wavelet responses in X and Y direction because image is a two-dimensional data. Then the sum of vertical and horizontal wavelet responses is calculated. Then the number of features extracted from each image. Each image here means one frame from the video. And we have to repeat this for every frame. So number of features extracted from every frame is 64, as this frame or image is divided into 4 by 4 square subregions, and 4 features are obtained from each subregion, right? So 1 4 by 4 means 16 pixels, 4 features are obtained. So after determining key points, comparison of consecutive frame is done using Euclidean distance. Then Euclidean distance between the two consecutive key points obtained from two frames is calculated. And if the key point is consecutive frame do not match, then those frames are selected as keyframes. So if key points means the important points, for example, you can consider, suppose there is a face image. What are the key points in the face image? Nose point, eye point, eyebrows point, lip point. These are the key point, for example, in a face detection area. Like this, in flower may be having particular key points. So from every frame, such key points are computed using SURF algorithm, and the difference between the key points using the Euclidean distance is computed, right? If the key points match, means frames are similar, they are not treated as keyframe. When they are dissimilar, right, then those are considered as keyframe. That is the meaning of if the key point in consecutive frame do not match, then those frames are selected as keyframes. There is a significant difference between the content of the two frames. Now frames whose key points match are similar and hence discarded. They are not considered as a keyframe. When they are sufficient dissimilar, then only those are considered as a keyframe. So let us see output of our proposed keyframe extraction algorithm. So this is a sample flower video database. We have used the same database which has been proposed by Dr. Guru in their research, who belongs to University of Mysore. They have published their paper in the Springer journal. So we are used the same video data for flower videos. So these are the sample flower videos, and this is an example of experimental result of keyframe extraction. So number one is the input image given to the keyframe extraction algorithm using SURF, and you can find that we are getting the keyframes which has got different orientation, different color, very less similarities there between feature similarity and not color similarity. So these are the keyframes identified. So we need not process every frame of the video. We will be processing further only the keyframes obtained from this algorithm. Then second video is a yellow Shevanti flower is there, and you can find the keyframes of these flowers which has got different sizes, different orientation. So these are the example keyframe extracted from the video database. Now, the second stage, if you see the block diagram of our research, the first stage was keyframe extraction. Second step is deep feature extraction using the deep CNN, right? So now let us see the proposed technique for extraction of deep feature extraction. So we have used AlexNet, which is a deep convolutional neural network for feature extraction. So in our research, we have used AlexNet for deep feature extraction. AlexNet was a pre-trained on 1 million images, right? 1 million means 1,000 images. So huge data was used to pre-train the AlexNet. Now other CNNs also were there. Why we have chosen the AlexNet? Because it was trained on 1 million images. Other CNNs were trained on more than 15 million images. So feature vector was large, giving rise to more more complex feature values at fully connected layer. Compared to other CNNs, AlexNet was more efficient and was requiring the small memory area compared to other CNNs for storage of the feature vector. So we have decided to use the AlexNet. So the feature values are simple in AlexNet. They give the superior performance. They require less training parameters and robust in nature. So these were the advantages of AlexNet. That's why we have chosen AlexNet. So in AlexNet, fully connected layers provide discriminant features. No? Different features, similar features are discarded, and discriminant features are obtained in the AlexNet, which are suitable for SVM classifier. So that further we can use the SVM classifier for classification of the input videos. So let us see how we have implemented the AlexNet. So the keyframes are used as inputs to the pre-trained AlexNet. So the output of the first step, these are the keyframes for the input videos. So these keyframes are used as an input, which was the output of last step, is used as input to the second step, which is called as pre-trained AlexNet. So all the keyframes were resized in AlexNet to 227 by 227 into 3. Now this was the requirement of AlexNet. So we have resized our keyframes to these sizes. So this is the length, height of the image and 3 channels, red, green and blue. And that's why 227 by 227 by 3 is the size of every frame we have supplied to the AlexNet. Now this AlexNet is an 8-layer network with 5 convolutional layers. So AlexNet has got 5 convolutional layers, convolutional 1 to convolutional 5. And the output of convolution 5th layer has been given to the fully connected layer. So the output of convolutional 5th layer is given to the fully connected layer FC6. Again, output of FC6 is given to FC7. Output of FC7 is given to the last layer called as FC8. So each convolutional layer in the AlexNet is followed by the rectifier linear unit called as ReLU, which is the activation function, and max pooling operation. So max pooling operation is used in AlexNet for downsampling. Again, here is the computation. To reduce the computation, the number of convolutional layer and max pooling layer are used. No? So why can't we use only one convolutional layer or only one max pool layer? Because normally in the real practice, the input images are of size 256 by 256 or 1026 by 1026 or maybe 2000 by 2000. Image can be of any size, right? So, and like this, we have to perform the repetitive operation on all the frames of video. So computation of all the pixels becomes very, very extensive, and we need a very large computing power as well as memory for implementation of the deep CNN. To reduce this, the complexity, time complexity as well as space complexity, the AlexNet uses 5 convolutional layer, so that in every convolutional layer we can resize the image size having only important features to the lesser dimension, and every max pool will downsample, means it will reduce the size of the image of the previous layer by 50%. You know, in the max pool, if the 2 by 2 is your kernel, it will be using only maximum value of those 4 pixels. So we can downsample the image by 1/4 size. That is the reason the AlexNet uses the 5 convolutional layer and 3 max pool layer, so that significantly can reduce the size of input image, but the features will not be lost. All the important features are carried forward to every next layer. Now, after the max pool 3 layer, after the convolutional 5th layer, the whole data, which is a 2-dimensional image data, that is 2-dimensional feature map, that is converted into a 1-dimensional feature map, that is called as flattening. So that is done in the fully connected one, having 384 features. Similarly, again, to reduce the size, the output of fully connected layer is given to the fully connected layer 2 Again, their number of filters are 384, and finally it is given to the softmax, which is reduced to the 1000 features, right? So output of the AlexNet is the softmax layer, which consists of 1000 values, right? So the last fully connected layer called as softmax layer, which gives the output classes of the classifier. Now convolutional layer extract features from input image using the convolution operation of image processing. It uses filters to produce the features from images. Important features are extracted from the images, and the size of the output of convolution layer depend on the number of filters and size of filters. And that's why we have got 5 layers to reduce the size of feature map further as much as possible. Hence, it reduces the size of input image and computation cost will be reduced a lot. And that's why AlexNet has become very popular nowadays, because whatever computers we are having normally used by people, the AlexNet can easily run on those computers. The previous deep convolutional networks were requiring large computing capacity and memory. That's why they were not used much. But AlexNet has become popular because it reduces the size of the input image considerably. Now, this output of convolutional layers, whatever we get, has got negative values as well as positive values. Now, to give to the output, we don't want negative values in the output. So we use the activation function called as ReLU, right? What does ReLU does? It will be passing the positive value as it is from the softmax layer to the final layer. And for all negative values, it makes 0, right? Negative values will not be passed to the output, but positive values will be passed and negative values will be made 0. And for that, we use the activation in the AlexNet. The ReLU function is used, which is an activation function. So this ReLU replaces all negative pixel values of feature map and by 0, so that negative values will not be there in the final feature map. Then we know that there are 3 pooling layers. What for the pooling layers are used? I have already explained. The pooling layers are used to reduce the dimension of the feature map, right? So there are different pooling operations available. One is called as max pooling and min pooling, right? So max pooling will be selecting the maximum value of that kernel. Suppose kernel is 2 by 2, then maximum value of all these 4 pixels is considered in the output. So you can downsample the image by 1/4. So in max pooling, the largest element is considered for the defined neighborhood, whatever kernel you specify. Then the network learn features of the input image in a hierarchical manner from convolutional layer 1 to 2, 2 to 3 till 5, and then fully connected layer. The initial layers learn low level features and subsequent layers learn high level features. These are depends on the filters used. So in the first layer, 96 filters are used, and similarly in the last layer, 384 filters are used in the AlexNet, so that all minute important features must be preserved. They should not be lost, right? So features are extracted from the fully connected layer FC6, FC7 and FC8 in the AlexNet. So the size of concatenated feature, which is called as the flattening conversion from a two-dimensional feature map to one-dimensional feature map. So this F6 and F7 fully connected layer gives us 4096 feature, and the last output of softmax converts this 4096 to all important 1000 features. So the total features used is 9192 in the AlexNet. So it is essential to reduce the number of features for saving computation and cost and time. See, though the output of AlexNet is very good, but the number of features generated by AlexNet are also huge. Those are 9192. So it is essential to reduce this feature vector as well for saving computation time and cost. So in our research, a feature selection algorithm is employed to select the most distinctive features. Again, similar features must be lived as it is, and dissimilar features must be considered. right? So in our research, we use the select features which are important, and those must be distinctive features. Similar features must be discarded and distinctive features must be used for further processing, because there is no point in processing the similar features again and again. Again, it will be waste of time and space. To avoid that, we use the feature selection algorithm from the concatenated deep feature. Now, why there is necessity of feature selection? The rich feature set obtained from the AlexNet, if used wisely, the word wisely is very important, because the feature map given by AlexNet is again huge. So we have to use this rich feature set wisely, which can provide advantage in the model performance. Directly using all the available features in the model can lead to computation inefficiency. Unnecessary, we will be wasting the processing power and memory of our computer in processing all the features. So we have to select the features from AlexNet wisely, right? So if we don't select the feature, it will lead to computation efficiency, high maintenance workload. So our inefficiency, high maintenance workload, and model interpretation difficulty will increase if we don't select the features. So normally used methods for feature selection are filter method, wrapper method, and embedded method. Now the advantage of filter method is the computation efficiency is more, and it has got the generalizability to different machine learning model, right? So filter based methods can be used by different machine learning model, not only the AlexNet. So it has got the generalizability. So in our research, we have used MR algorithm, right, called as minimum and maximum relevance method for feature selection. So the motivation to use MR method is that it can effectively reduce the redundant features. So whatever repetitive features are there, which is output from AlexNet, those are reduced or discarded while keeping the relevant features for the model. So this MR algorithm keeps all the relevant features and it discards the redundant features. And that's why it is our third step. If you see the model of our proposed research is that the first step is to accept the flower video database, then computes the keyframes from the flower videos. Sorry. And these keyframes are given to the deep feature extraction step, where we have used AlexNet to extract the deep features from the keyframes, not from every frame, to reduce the again complexity. And from that, the feature map of AlexNet, we select the features from the feature map, which reduces the size required for the storage of feature vector. And for that, we use the MR algorithm. So let us see now how does this MR algorithm is implemented in our research. So this is feature ranking and selection, minimum redundancy and maximum relevance algorithm, right? In short, it is called as MR algorithm. So this MR algorithm finds each attribute as a separate coincidence variable, and it uses mutual information I of x comma y in the feature vector among them to measure the level of similarity between the two attributes. Here, two attributes means two features, right? So this, the separate coincidence variable and use of mutual information I of x comma y is denoted as summation. It uses the probability density function to compute the similarity between the two attributes shown by this formula. So in this formula, P of x comma y represents the combined probability distribution function of x and y, right? So P of x comma y is a combined probability distribution function, and P1 of x and P2 of y represent the marginal probability distribution function, right? So P of xy is the combined probability distribution function, and P1 of x and P2 of y is the marginal probability distribution function of coincidence of variables of x and y respectively. So to facilitate equation, each attribute defined as a vector form by sorting n features. So whatever the output of AlexNet we have obtained for that frame is sorted in the form of f of I, feature vector, in which all the sorted features are there. F1, Fi1, Fi2, Fi3, all the features till Fin. So this is a feature vector which is in the sorted fashion. So here f of I is treated as an example of a discrete coincidence variable. So every feature in this feature vector is treated as discrete coincidence variable, and mutual information between I and j attributes is defined as I of f of I comma j. So where this I and j are ranging between 1 to d, and d represents the number of feature vector. So for every feature vector, a value I of f of I comma f of j is calculated, which is called as a coincidence variable and mutual information between I comma j. Now let S be the set of selected features. So these are the original features, n features. We know that lot of redundancy is there in these n features. All features are not the distinct feature. There can be many similar features which should be discarded, and for that we are using MR algorithm, right? So let S be the set of selected features. We want only S features in the output, and S in the bar shows the number of selected features, right? Now our aim is to compute S, that is set of selected features from the total features n obtained from AlexNet. So here the first condition to select best features is called as minimum redundancy condition. So in this step, we will be selecting the minimum redundant features. The features must be discrete. They should be distinct. There should be very minimum redundancy, means repetition in the features should be there. That is computed using this formula. And the other condition is named as maximum relevance condition, okay, which is given by the formula. And the two simple combinations that combine the two conditions can be denoted by the following equations, right? So the combination of these two conditions is denoted by max of V minus W and max of V by W. So the search algorithm is required to select the best number of features, and primarily the first feature is selected by the minimum of W comma W, this formula, okay? So at each step, the feature with the highest feature importance score is added to the selected feature set, and this is how we get the selected features using MR algorithm. Now, the last step of the proposed model is the generation of support vector. So if you see in the diagram, this is the fourth step of our model. That is, once we get the selected features, these selected features are used for generation of support vectors, right? Which gives us the different classes of videos and which is stored as a knowledge based. Right? So let us see how the last step is implemented in our research. So the last step is video classification. We have used multi-class support vector machine SVM classifier for determining the labels of the flower videos. This multi-class classification using SVM is done by breaking the multi-classification problem into smaller sub-problems named as one versus all and one versus one. So there are two type of video classification using support vector machine is there. One category is called as one versus all, and another category is called as one versus one. So one versus one is a binary classifier. This is called as binary classifier. Binary classifier means it gives only two classes. So whole input data is classified either in class 1 or in class 2. So there are only two possibilities. And this another category is one versus all. This classifier separate one class from other classes. So we can have number of classes using one versus all classifier, while we can have only two classes using one versus one classifier. So obviously in our research we have used one versus all classifier because there are number of classes of videos, right? So binary classifier is of no use for our work. So we have used one versus all classifier that separates one class from other class. So let's C1, C2, Cn be the n number of classes in which we want to classify our data. So let S1, S2, Sm are the support vectors which are used for classification of the above classes. So in general, this class C of I is given by this equation where C of I consists of set of support vectors. Total support vectors means those are hyperplanes which classify our data. Those are denoted by C of I. Those are the classes, and support vectors are S of J. They separate the nth class from all other classes. So number of classes we get is equals to C of I based on number of hyperplanes, or those are called as support vectors as S of J. The discriminant feature obtained in the second stage is the SVM classifier to classify the flower images, right? So I have got one more image, right, which, just a minute, I'm loading one more PPT which has got so I want one more diagram to be shown, which is available in another PPT. Just a minute, I'm loading it. Yeah, I think that figure is not here. Okay, I will explain with the same figure. So this is a support vector machines model explained with the figure where we have got one hyperplane which is a support vector which has got certain margin. So left hand side of the margin is the class classified into class 1, and right hand side of the margin is the class classified into second class, right? So those are shown here in a different shape. Circle is the all data classified in class 1, and square in maroon color is another class classified into the second class, right? Now for our experimentation, we have used the flower video data set. This dataset consists of 2,707 videos. This dataset was generated by Dr. Guru, who is a professor at University of Mysore. So we have got this database from him. We have used the same database he has used in his research paper, and we have compared our results with his results. So this dataset generated by Mysore University consists of 2,707 videos with 30 different classes of flowers, in which each class containing 35 to 160 videos in every class. So the videos are captured with a duration which ranges from 4 to 60 seconds. And the videos collected have a huge intra and interclass variation. We have already seen that this is the main hurdle or main challenge in classification of flower video, that there is a large intra and interclass variation among the flowers. So we have used the same type of video to test performance of our proposed model. So there exist challenges such as variation in viewpoint, lightning variation, illumination variation, then partial occlusion of leaves, stems, and background of the flower is cluttered. So purposefully we have used the database which has got all these type of challenges, right? So let us see the experimental results of our proposed model. So to determine classification accuracy, different data partition scenarios were considered in the experiment. So we have got various type of training models used, 30% training, 70% testing. Then we have also used 40% training, 60% testing, then 80% training, 20% testing, and so on. So it was observed that 80% training and 20% testing partition provides highest classification accuracy of 98.2%, which is better than the existing method. So we have got 98.2% classification accuracy with the proposed model. So these are the experimental result. For 30% training and 70% testing, we have got the classification accuracy 92.61, and this method did not use the feature selection, the old approach, and our proposed approach, which uses the feature selection and deep CNN, the classification accuracy is increased by 92.9. Then for 40-60, the accuracy achieved was for 94.8. For 50-50 training and testing, our approach gave the 94.1% classification accuracy. For 60% training and 40% testing, now the classification accuracy is improved to 95. In 70-30, the classification accuracy is improved to 97.5. And in 80-20, 80% training and 20% testing, the old method, existing method gives 97.79 classification accuracy, while our proposed selected deep feature method gives 98.2 accuracy. So you can see that significant improvement is there in the classification accuracy when we use the AlexNet and MR feature selection algorithm in combination. So the comparison of classification accuracy shown. The yellow bar is the existing method and black bar is our proposed approach. You can see that there is a significant improvement in the classification accuracy achieved. So in this research, the conclusion is an accurate and efficient flower video classification system based on deep feature extraction using AlexNet is presented. In this approach, to select relevant features, feature ranking is done using the minimum redundancy, maximum relevance, that is MR algorithm. Then it is revealed that fully connected layer F8, which is the 8th layer of AlexNet, it provides more prominent image features compared with F6 and F7 for flower classification problem. Is the last layer gives the most prominent image features for flower classification problem of AlexNet. Further, multi-class SVM classifier is used for classification. Then classification accuracy of proposed method is studied for different number of features selected from fully connected layer. Then comparison accuracy of 98.2% was achieved for a dataset consisting 2,707 videos prepared by University of Mysore, which is far better compared with the existing methods. And finally, it is revealed that the proposed approach is efficient and very much useful for flower classification. Thank you. So I would like to take questions.
Thank you, ma'am. Thank you, ma'am.
Yes.
Thank you for enlightening the knowledge of deep learning, applications of deep learning, and a case study of flower video class using selected deep feature extraction using LXNet. Thank you, ma'am. It was a great pleasure listening to you. Now I would like the participants, if you have any queries, unmute yourself and ask the question to ma'am. Or you can post it in the chat box.
Hello.
Hello, yes, sir, you are audible.
Yes, ma'am. So very nice presentation by Archana ma'am. So thank you for your valuable guidance. So ma'am, actually I'm working on deep neural network, and my difficulties levels are there. Actually, the data set used by the author, it is the too much high, or which is available in a GB. So can I take some part of the data set for my evolution purpose, and whatever the result I will get, whether it will be the appropriate to claim my that claim, ma'am?
See, if you want to compare your results with that technique and you want to publish a paper in a good journal or conference, you have to use the same data set. Because if you reduce the data set, the parameters of your case and their case is going to be totally different. So you cannot compare. And if you cannot compare, you cannot claim that your technique is better than theirs. And without there is a valid claim, your publication will not be accepted in good journal or conference. You can try with the less number of data set, see the results. If you are getting good results, then you can expand the data set. Right? That you can do step by step. And you can use the GPUs. Currently, there are many GPUs available in the cloud. They are paid as well as free also, through Google and all. So you can take the resources which are available online. In currently pandemic situation, everybody is working online. So many GPUs are available. So you can hire them for your purpose and then expand the data set and take the results on the GPUs. So you will not be facing any hardware problems. The main hurdle in deep neural network is the hardware, because most of us, we are using Pentium machines, i3, i7, and i7 is not sufficient at all for implementation of the deep sea.
Yes, ma'am. And that is only the reason I thought that if I could only take some subset of the original data set to reduce the hardware complexity. So I thought in that direction. That's why I have asked this question.
As a first step, you can do. See, as a first step, you can do implement the whole model and work with the small data set. Once you're getting the result, you can hire any GPU available online with a payment, bigger payment, not very much. And then you can implement the actual on data set. Without that, your publication will not be accepted internationally.
Okay, thank you, ma'am.
Hello, ma'am.
Hello, Aarti. How are you?
I'm good, ma'am. How are you?
Fine, fine. You're in the same college?
Thanks a lot. It was really a great insight what I have got, because even I'm working in the same field. I'm guiding students also. Just a question, ma'am. I'm audible?
Yeah, your
Yes,
voice
ma'am,
is
you are
breaking,
audible.
Aarti.
Hello, am I audible?
Yeah, now it's clear.
Yes. Just I wanted to know one thing, like how it would be use of TensorFlow or this library for this. If I want to make use of either TensorFlow or YOLO, which you suggest for this, ma'am?
See what paper you are implementing. That first you have to see, and what data set they have used. Because see, in every CNN application, whatever you design, you have to compare with the existing work. Because most of us, we are doing incremental research. So first you have to try with the data set given in the model you are implementing, right? Once you get the good results as per that author, then you can try with the other data sets.
Other data sets. Okay, ma'am.
Yeah.
Ma'am,
But
if at
first
all,
you have to,
if you want to
try
create
on
my
the
own,
given in the paper.
all right, ma'am. If at all I want to create my own data sets, what would be the insights for this, ma'am? Because
no, you can design your own. I will give you contact of Dr. Guru. He has created the data set, but you have to publish it first internationally, so that it is accepted by the international research community as a standard. Right?
All right.
So
Okay.
for that,
Should be
you have to follow certain norms and publish a paper. Once that paper get published, then you can use that data set for the further research. That will be good idea. But again, it is quite a rigorous task. Create a data set and standardize it. You cannot create your own videos and say that it is my data and these are my results. Nobody will accept it.
Yes, ma'am. Yeah. What you said is right. Yes, ma'am. Thank you, ma'am. Thanks a lot. Thanks a lot.
Nice seeing you after so long.
Yes, ma'am. Same here. I was longing for this day. Thank you.
Thank you, ma'am. Any other participant would like to ask the question?
It was a wonderful session, madam. Thank you very much. I think it has taken back at least 15, 16 years when you used to teach us in the class, madam. It was the same tone, same.
It's a multimedia. I know.
Yeah.
I remember.
Yes, ma'am. And
it's a great day what we had, and she gave a great knowledge, and that we are actually using in our profession. Thank you, ma'am.
And whatever we are today, it is all your blessings, madam. And we just try to follow your footsteps, madam. Just
Thank you so much.
Wanted to.
It made me as well nostalgic. I also remember in 2003. It was almost 18, 19 years. Very good, good student batches.
Idol for us, always idol for us. And I never thought I will be into this stream and into this domain. I'll be working like this. I'm into image processing, AI, and ML now.
Nice to know. Very good to know. Both of you have progressed a lot. I feel very glad that Gndecb also has completed his doctorate, and now he's head of the department of CSU. A very good college.
Thank you.
Very glad.
Thank you, ma'am. Nice seeing you. Thanks a lot. Thank you.
Even Aarti ma'am is also HOD, madam. No.
Yeah, congratulations, Aarti. Nice.
I'll call you. I'll call you.
Yeah. No, I also have. I'm very, very happy to see that our students are progressing so nicely, and they're doing very good work. This BP, I am listening since first day. It was organized in a very, very well manner. Very good speakers are there. Congratulations, Gndecb. And at the outset, I would like to thank the organizers, the management, principal, HOD, and coordinator for inviting me and giving me opportunity to share our research work. This is the work by one of my research scholar, Mangal Banvaskar madam. I thank her as well for providing me all data, all information. And because of you all, I am also deriving pleasure by distributing the knowledge. If you keep the knowledge at one place, it is of no use. When it reaches to the maximum people, a teacher has got the most satisfaction by that only. And thank you for giving me that satisfaction, Anna. I'm feeling very glad to see you after so long. Keep in touch.
Yes, definitely.
Sure. Definitely. I'll do that right now.
Definitely. Definitely. You just guided us how exactly the presentation has to be done, right from the scratch, taking the problem and solving it step by step, and how well you have explained it. I think that will motivate a lot to all the teachers, like how exactly, because many of us, we work a lot, but how exactly it has to be presented. I think you're given the best example, like how it has to be presented. So thank you very much, madam. So
Most welcome.
yeah,
Most welcome.
I don't think that there are any other questions from any participants. So thank you very much, madam, for sharing your valuable time and taking uh, and delivering a session as a resource person to this AICT, IST, FDP on machine learning with the Python. And it is all because of the speakers. These sessions are going very well, madam. So thank you very much to all the speakers uh, who have been actively, I think till today, not even a single speaker has missed it. And everyone sessions are very good.
Very
And
nicely going on. I am also
yeah,
attending whenever possible. Very
yeah,
good.
yeah, that is true, madam. Okay, madam. Thank you very much, madam. So
Okay.
thank you.
Thanks a lot.
Dhananjay sir, you want to say anything?
Hello, good afternoon, madam.
Good afternoon.
So it was a very nice presentation, madam. And like what happens, like when we go into the research, there are many tools, and probably sometimes we don't know what is to be used. And probably like there was one question I posted, even like when it comes to deep learning, are they more relevant when for image processing, or they can also be utilized for other problems?
Pardon? Your question is CNN are more relevant for image-based classification or they can be used in other problems. See, CNNs are used in a wide range of problems. If you see the Alexa, which is a
Yes.
product of Amazon, you ask any question to Alexa, it is related to speech recognition. So there deep CNN is used. So when we ask any question to Alexa, Alexa immediately replies us. It may be songs of Lata Mangeshkar, it may be today's temperature, it may be today's date, time, it may be today's news. You ask any such question, Alexa will immediately reply you. Again, another application I have explained, that is Siri on Apple. You can give voice command, it's voice recognition. All these applications are deep CNN applications. So now why CNN has become now currently popular in image processing? Because they have shown very good result in the image retrieval and image classification and object recognition, especially in the face recognition, vehicle recognition. Deep CNN has shown the outstanding performance, and that's why they have become currently in last few years very popular in the area of image. But they can be used in many areas. You know, I have explained you that the driverless car application through CNN, whenever there is learning something automatically, right? That is because of the CNN. Application can be anything. It can be virtual assistant. You know, if you see any online site, immediately you visit that site, you will get assistant, and that is a chatbot. You know, chatbot is also machine learning application through which automatically system is replying to you. If I'm searching some product, I don't see particular color, particular size, I can ask to that assistant if I got any order related problem. So that chatbot is no person is there, it's a humanless application, and that is replying because standard questions and answers are already fed, and from the questions it learns itself, and this step goes on, and that assistant become expert in few days. All these applications are CNN applications.
Thank
They
you,
have
madam.
become
Like,
very popular
yeah.
in last 10 years because the hardware cost reduced a lot. Previously, hardware cost was huge and layman could not afford it. So if the product is not affordable by people, who will produce them? Because all the business is when the product is sold to maximum number of people, there is a profit. And that's why last 10 to 15 years, there was quite slowdown in the research of AI machine learning. But in last few years, it has got increased exponentially, we can say, because the hardware cost is reduced a lot.
Madam, the results that were presented were
Uh,
outcome of a MATLAB implementation or a
yes, yes.
Python implementation.
MATLAB implementation. My
Okay, madam.
student, PhD student is working in MATLAB only. But we can
Okay.
implement in Python. You know, see, language is not a barrier for anything. It is a tool. You can use any tool. concepts, and the mathematics is more important.
Right, madam. Thank you, madam. Thank you for your like detailed description of my question. And I also thank from behalf of my management, my staff, colleagues, and my team. It was a very wonderful, nice session, and we will be very happy if you could take time and come down to our college and have a visit and also guide us in our next endeavors. And thank you, ma'am. Thank you for giving us a time and joining us this session. And I'm very thankful to even like the Dayanand sir, who in fact was the point from where I could contact you. Thank you
Thank you.
once again
Thank you.
from
Thank
behalf
you.
of
I am
all.
ready to come to your institute anytime. No, Nanded is not far away from Bidar. We will see a very good opportunity once the corona is over, maybe next 6 months.
Yes, sir.
And so
Always
you,
it
you
will be
people
our
also come
pleasure.
to our college. We will also come to your institute.
Yeah, madam. It will be a pleasure to host you in our college. Thank you, madam. Thank you.
Okay. Thank you. Thank you so
Thank
much.
you.
It was nice seeing you all. Bye.
Thank you. Bye, ma'am. Thank you. Thank you. Thank you. Thank you. Recording stop.
Of machine learning using Python. So, in the morning session, we had discussed about image processing and all, and I got a request that why don't we go for using some sort of MRI images, and by using those images, how we are going to process the things in machine learning. So, coming to this part of the session, we are going to create a CNN model that can classify X-ray images as whether they are whether the disease called pneumonia is true or false, whether they are in a pneumonia state or in a normal case. And first of all, talking about CNN, its long form comes up as convolutional neural network, which is a deep learning algorithm which can take the inputs in the form of images and assign some important way, I mean, aspects such as weights and biases and to the various objects that are present in the images, and it can also differentiate from one another. So before moving on to this one, we need a data set, and that data set we are going to take it from the Kaggle. Kaggle is one of the famous machine learning notebooks that we can somewhat like Google Colab itself. We can also use Kaggle also. So coming to the part of the data set, actually this data set is going to use for the image classification of the chest X-ray images, which is basically going to consist of two categories. One is pneumonia and normal. So this data set was published by Paulo Brivigeri, a revised version of Paul Mooney's most popular data set. So this data set is basically going to consist of three folders, which has train, test, and val folders, which even has some subfolders with the image categorized based on whether the patient is uh, having pneumonia or not. So it has more than 5,000 or more than 5,500 images, which has some different categories of patients who has pneumonia or not. So we have all the all the images available in the data set, and we are going to first of all download the data set. First of all, I'll be presenting my screen. So before moving on, to the making of dataset, I'll be first of all I'll go to Kaggle. I'll be taking the dataset from there. Kaggle, we can just go and click on Kaggle, and we need to sign up on the Kaggle. If we have signed up, then we need to go to accounts. You can see here we have one option called accounts on the right side. Just we need to click on accounts, and once we go down, there is an option called using Kaggle's beta API, and we can create a new API token. And for this, I'll be creating one new API. So it will be downloaded as an as a JSON file, and we'll be using this for writing and using it in our as we are working on collab. So this needs some sort of importing things so that we can import all the data that is present in our data set, that is from Kaggle that we are using. And you all can see that we are not having anything on the on our file section apart from sample data, which consists of the regular files and all. So from here we'll be using, will be allowing and some regular imports, and will allow and install also Kaggle. So for that I'll be saying pip install Kaggle, and I need the dataset also, and I need to upload the API token that was downloaded from our file. And for this I need the Google Colab, google.colab from Google Colab. I want to import files, and I want to files dot upload, and I'll be creating a directory that is going to say mkdir tilde slash dot Kaggle.
What is PIP?
Sorry? Okay, I forgot to say, pip is actually a package manager which is going to install all the necessary, packages for Kaggle. So if you are working on something like pandas, then we need the library to be working on. So for that, we need to install it. So PIP is nothing but a package manager which is going to install the library. So over here we are installing Kaggle. So for this Kaggle, it is going to install all the necessary files for our further workings, and we'll be installing all the datasets by using the Kaggle API itself. So I'll be creating a directory in Kaggle, cp. I want to upload my Kaggle files, so I'll say kaggle.json. So this is the syntax that we are going to use for uploading our files, slash, and the ch mode should always be of 600 for editing purpose. Kaggle slash kaggle.json. So over here we need to upload the API file that we have downloaded from Kaggle. So for this, I need to run the file. Okay. Chmod Kaggle invalid syntax. From Kaggle, load mkdir Kaggle chmod. Kaggle/Kaggle JSON. So I have made some mistake. mkdir files.upload mkdir cp kaggle.json kaggle. Sorry, just a silly mistake. I had to give this over here and run. So over here, this is asking us for uploading of a file. So anyhow, we have downloaded the JSON file of Kaggle. So I'll be clicking on choose file and I'll upload and cannot start no such file or directory. Okay, fine. Okay, let me just refresh. I guess due to the name, it is showing an error. Okay, so this is saying that file is already existing. So this means that we have already saved the file, so no need of saving it again. Now that we have taken Kaggle into our file system over here, so already Kaggle.json is present, and I had to actually rename this one, but anyhow, no issues, but both the things are going to work. Over here, now I need that it should display Kaggle dataset should be downloaded now. Datasets download. So I'll be giving the name of the file that we are going to download. PCB Revigilary slash pneumonia X-ray images. So I'll be saying that all the necessary dataset files should be downloaded by just saying Kaggle datasets download PCB Revelgary pneumonia X-ray images. I'll just run and download the unauthorized. Just check out and search pneumonia. So here is the overall dataset available, and either we can download it manually, or either we can even download. Just we'll click on download, and I guess this should work fine. It is taking a huge amount of time. Or not one unauthorized. Let me just try this by just deleting the file. Let me just try this and working again. Cancel upload. 404 not found. I think the dataset is present and the download is also very much slow. We'll just try some other way. 404 not found. Let me just copy this and open a new notebook for ourselves. We'll run our kaggle.json file from here in a new notebook. Choose files, kaggle.json. Okay, now I guess we can run our next line of file that we had written. That was just due to the name of the files that we had uploaded. Unauthorized. Even this file is downloading late. Datasets. download. Let me just check whether they have provided any link to download this. Directories. Or let me just upload one of the zip file. We need to wait until this is going to upload. I don't know why they have removed this, because we are going to download it in this way itself. Unauthorized. Kaggle.json. Okay, I'll just rename the zip file that is being provided by saying pneumonia X-ray images, so that we can use this. X-ray images. So there is no need of downloading it manually, because I had to do it from the Kaggle itself directly. So I'll be writing the next line of code where because we have uploaded a zip file, and now I want this file, which is a zip file, to be extracting all the files and saving it in a folder. Import zip file. Zip file will be taking a variable which is going to store it content slash pneumonia X-ray images, and we'll be giving a target of directory which is going to be, this should be our zip file that we have renamed, and where they should be stored. I'll copy everything, and content, I don't want this to be I want it should be of dataset slash CNN folder, and it should pneumonia underscore revamped. So I want that our zip file should be extracted and stored in content dataset CNN pneumonia revamped folder. So we can even check this. Once this is done, zip file equals to zip file dot zip file of ZF, and after this we'll just zip file dot say we are going to extract all to the targeted directory, target underscore dir, and we'll run this one now. Module, I guess a lot of errors are being occurred. Zip file dot, okay, sorry, some spelling mistakes. Zip file of ZF, the data set. Zip file, yeah, capital F, import zip file, zip file dot file is not a zip file. Okay, sorry, this is because our zip file is being still uploading. A lot of let me just check out. Either they have changed this. Sorry, they have removed, I guess, directory showing empty. Just try it again. Uh, Let me just download it once again. I guess maybe my API was not created properly. Count. Let's remove all the cannot create a root directory file exists. Let me just try with this. Kaggle datasets. Download. This is also taking, the uploading is taking a lot of time. To check out. actually. So I will take this one. This is saying Kaggle API. Let me just expire all the API tokens. Okay. And delete this one too. And create a new API. Kaggle.json. Let me just close all these things also. And create a new notebook. Which is going to allow us choose a file of Kaggle. Loading done. I'll just take the images from this one. Okay, now this is, I guess I had made some sort of mistake, and now we are downloading our dataset, and which is being downloaded pretty easily. And over here, if you all can see, there is pneumonia x-ray images.zip file, and to this and to this zip file, now we need to extract it. I'll be writing the same code again because I don't already a lot of time has been wasted. So I'll copy this one and I'll paste, and I want that this file should be showing, and this file is going to extract the zip file of this pneumonia uh, that we have downloaded right now, that is pneumonia x-ray images. And I'll run this one. This should extract a dataset folder, CNN folder, and within that pneumonia revamped data should be present in that. And this is run, and here now we can see that dataset has been created, dataset folder, and within this we have the CNN folder and pneumonia revamped folder, and the all the pre-trained modules that are present in within these folders. One is test folder, train folder, val folder, and within this we have other two different folders that consist of normal images, normal patient images. Opacity means the patients who are infected with pneumonia. And in trained images, we have again normal as well as the person who have been infected with pneumonia. All the images have been entered over here. And likewise we have the val folder also. Now as we are done up with all the things of taking our dataset into our code, now directly I'll just go for importing our matplotlib dot pyplot as plt, and I'll import some numpy, import numpy as np, and I'll be importing import pandas as pd. And let me just execute this one and find out whether we are getting any sort of error. Okay, we are getting no error. Now, as though we have been writing all the files and all the augmented files, but before going to that, we need to check out whether all the files or all the important things are being loaded or not. And we will be checking whether how many files and how many trained datasets are present. So for that, we'll be writing the code from TensorFlow TensorFlow.keras dot preprocessing dot image import image data generator, comma array underscore 2 underscore img tag img. So over here we are saying TensorFlow to upload its pre-processing imaging data, and through this we'll be checking out what amount of data do we have. Image data generator, and to this we'll be having rescaling equals to 1 point divided by 255, and we have range shear range equals to 0.2, comma and zoom underscore range equals to 0.2, comma horizontal underscore flip equals to true, and we'll close it here itself. And now we'll be trying to check out our test underscore data underscore gen equals to image data generator rescale equals to 1 point divided by 255. So after this, I guess already a lot of time has been wasted. I'll just copy and paste the code so that nothing can be missed out, so that we can check out the data, and I'll also be explaining the test and the things that we are doing. Just a minute. If I keep on typing, it will take a lot of time. Over here, I'll just check out my mail. So over here, we'll be having some sort of data from my mail itself. To this, I'll be taking the data and I'll be typing it over here. So over here, we are just trying to do some training sessions, and we will be displaying the number of images that are available in our data set. Refresh. Train path. What is this happening? Equal to train path. Data scaling. Path year to IMG. Train equal to train path. By train path. Scaling over here. Saving, importing zip file, pandas, grayscale. path is not defined. If I try to check out outline, type of train is not defined. Wait a minute, sir. Train, I guess I am just missing some code over here after this. I guess I have forgot to mention the train path, that is train underscore path equals to our content set slash train, and I'll copy the same thing. And this, I'll be setting this as a test path for our test, and this will be the valid path. Valid. This will be for test, and this will be the train val folder that we are using. If I run this, okay, this is working fine. Now we should not get any kind of an error. Image height, image width. Image. So I'll be taking this as a batch underscore size of 16, and I'll be taking the image height equals to 500 pixels and image width equals to 500 pixels. Now I guess this should not get any error now. Okay, finally this is worked, and over here we can see the number of images in all of our file are, I mean in the data set that we have created is 4192 images belonging to two classes, and 624 images belonging to two classes, and 1400 images belonging to two classes. So this means that we are having 4192 images in test, and train we have 624, and in valid folder we'll be having 1040 images that are available. And if I try to check out the train, and this is going to display that it is being processed from our trained Keras pre-processing image directory iterator, and I have taken the code for displaying the number of images. Sorry about all these mistakes, just due to some errors and all at the not at the right point of the session. So over here, I'll be taking one figure size where it will be mentioning I'll be taking the size of 20 of 12, and for this, I'll be adding one for each loop with the range of 10 images to be displayed with every batch, and this should display whether they are in a normal state or whether it is the patient is affected by pneumonia or not, and that should be with a grayscale CMAP. CMAP we have already seen in the morning also, so it should be interpolation should be the nearest values, and they should display it in a with the overall images. They should display the images, the people who are affected by pneumonia as well as the people who are normal has some sort and some different image scaling points over here. We are displaying some different X-ray sites which are going to be probabilized with some different cases, like whether they are normal or whether they are in a state of pneumonia. So once we are after this, then I need to reevaluate the things in a JS where I'll be mentioning different things. So featured, standardized, all the things I'll be mentioning in this code, and refresh. So, and after this, we will be adding our TensorFlows. TensorFlow, I'll be just directly taking it because we have wasted a lot of time. And from TensorFlow, I'll be saying that import sequential load model and save model and dense convolutional 2D flatten max pooling 2D early stopping reduce run plateau. So all these libraries I'll be fetching, and from there I'll be saying, and now I'll be building up a CNN model which is going to display our data. And if I run this, it should now go for compiling purpose, and from here we'll be checking out what will be the summary of all these previous executed data. I'll just run this one, and this is going to display the sequential kind of a thing where the shape of the X-rays are being displayed with conv v2d and max pooling. We are going to discuss this and flatten also, and what is the density of the images and all. And total parameters 1 lakh I guess not 1 lakh, it's 1467137, and trainable parameters, same thing, and non-trainable parameters. So this says that we don't have anything to be um, training, we don't need anything to be training purpose for here. And within this, we'll be checking out it in a proper manner of a flowchart. TensorFlow dot keras dot utils will be import plot, will be creating a plot model, and with the same thing we'll be having plot underscore mode, a CNN model which is going to display show shapes equals to true, comma, show layer underscore names equals to true, and we'll be saying a rank dir of tb, comma, expand underscore nested. So I could have explained all these things, but we are just running out of time. Run this one. Plot mode is not defined. What is this? Yeah, what is happening? Sorry, I have missed this as plot model, and run this one. Okay, so here this is going to give us a proper flowchart of the trained models as well as max pooling 2D, 3D, and conv 2D. All the inputs, outputs are being mentioned and given in the diagram itself. And this file will be saved if I minimize this one, and this model.png file will be stored in our file section. And from here also we can download the layer, latest, if you want to download this, we can download it from here. And the next thing that we will be adding here will be fitting the models, and will be taking early equal to early stopping, which will monitor our valid loss, equals to minimum, comma, this will be the mode, and patience equal to 3. So we are saying that this should be going to fit into our model, and we'll be saying learning rate of the model reduction equal to reduction on Plato monitor equals to val underscore loss, comma, patience equal to 2, comma, verbose equal to 1, factor equal to 0.3, comma, minimum LR will be 0.00001. So this will be the learning state, and after this I need callbacks underscore list equals to early comma learning underscore rate reduction. So this is for our fitting purpose, and now we will write the code from our sklearn sklearn.utils dot class weight import compute class weight, and to this weights, let me just calculate it from different way. We can just take it from, I'll be saying weights equal to compute underscore class underscore weight of class underscore weight is going to be balanced, and for this we'll be again taking some sort of classes equal to our train dot classes, comma y equals to train dot classes. So I'm trying to mention all the different ways of CNN, and we'll be taking or computing the weights, and after this I'll take a variable called CW, which is going to be a dictionary type of zip file, which is going to be np.unique, and it will be train dot classes, and we'll be having the weights. And I'll be printing print CW. And CW directory iterator object has no attribute classes. Sorry, the spelling mistakes. Okay, so here we'll be getting and computing the weights of the training model that we have written. And after this we'll allow here to make the fitting for our epochs that is going to take and display all the history, and will be, by using the history of the epochs, we'll be displaying the pigmentation on our x-rays. So I'll say cnn.fit train comma epochs, and this is going to take some amount of, I'll take only 15, I'll take 10. If I'll take more than 10, then a lot of time will take, because it has to be done, because apart from waiting, we don't have any choice for this one. Valid comma class weight will be CW, comma, callbacks will be the callbacks list. And now this is going to take some amount of time so that our epochs are going to be executed. Allowed positional argument followed keyword argument. And this should be validation data equal to be valid plus this should be single. Okay, now our epochs are being running, and this is going to take some amount of time so that all the epochs and all the images will be checking all the things, and by using this history of epoch we'll be executing our models and will be saying it into the will be displaying it in a matter of histogram, or will be displaying it in some data frame or something else. So this will take some amount of time. It's taking time, but we cannot even proceed until this is done, because we need the history of the trained models. So till this is going to execute, I'll just complete the rest of the coding so that we'll be not wasting the time. FP. So I'll be taking one trained model from our content slash. Now I have to connect it to my drive, where I have already saved CNN underscore PNEU underscore vamp underscore model dot h5. So this is already a trained model that I have stored in my drive, and this drive is going to execute, and we can save this equals to load underscore model of FP. So this model will be loaded from my file. So if I'll be checking drive, I'll be mounting my connect to Google Drive, mounting Google Drive, and once this mounting is done, so I have already saved the file, and you can also just download it just by searching anywhere in the Google, something like connect file.h file. At the end of the session, I'll be sharing all the files. You can download it in this way also, and this WAM file will be downloaded, which is going to consist of all the trained models of our CNN model, which is being trained for all the images. And you can store that file into your Google Drive in this Google Drive in this format, and from there we can load it. And once we are going to load this one, we'll be writing the CNN dot predict underscore segmentation, and once this is done, we'll be evaluating the code, something like pd dot we want a data frame which is going to display all our CNN dot history. Once the history, the epoch that is running above, this is going based on that history, it is going to display a chart, we can say a chart which is going to be having all the details of our CNN model. And after this, we can test our accuracy. Test underscore ACCU, which consists of CNN dot evaluate the test, and they should print the testing accuracy is, and after this give a comma. They should give test underscore ACCU with the value of 1 into 100 percentage. And once the testing is being done, we'll be writing one more code which is going to say prediction equal to CNN dot predict the test value, comma, verbose equals to 1. And after this, we'll be having the prediction code. I guess I have already taken this in the mail. So this is our pd.data where we'll be taking all the predictions into a file. And one more code from SK matrix we'll be writing and fetching the actual as well as all the metrics that are defined. And after this, we'll be writing and saying a printing out step, which is going to classification underscore report y underscore true equals to test dot classes, comma y underscore pred equals to prediction, comma target underscore names equals to normal, comma pneumonia. So this should predict the values for us. And after this, we should test and reset our file. Control V. And after this, we'll be mentioning one dictionary which is going to print and show the tested images for us. Control V. So I have done I guess our epochs is still running. I don't know. So if this is going to execute fast in 5 to 10 minutes, then we'll proceed. So this epoch is going to take all the necessary conditions that are that we have trained, and that is going to validate, and it is going to check what is the accuracy of whether the patient is having pneumonia or not. So this dataset has all the X-rays which are normal as well as which are having pneumonia patients also. I mean, even what percent of pneumonia uh, is present, we can also testify that also. Or I can do one more thing over here because my drive is taking too long. So I'll just upload the model here itself, and once my model is being loaded, so I'll take the path, copy path, and rather than going to my Google Drive, because I have a huge amount of files, so this is saying this may take long time to complete if you have large number of files in Google Drive. So anyhow, let me just test it out until this is done. And sorry about the time that we have wasted in silly kind of errors, and we could have done it more better and we could have saved a lot of time, but this was not possible. Yes, this is going to take a lot of time because we have given 10 iterations of epochs, and again one more epochs. Likewise, we need to go for 10 more epochs to be executed. So this is going to take a lot of time. Anyhow, after this session, I'll be sharing my notebook with you all. You can go through this. If I interrupt over here, then maybe the files are not going to work properly. I mean, the below code is not going to work fine. So here, this is displaying the accuracy as well as the loss that has been done by the images. We'll wait for 5 more minutes. If this is done, then we can proceed, or else we'll just wind up and I'll be sharing the notebook with you all directly. This will take a lot of time. Guru Prasad sir.
Yes, sir.
Um, Sir, so shall we wind up? So, I guess this is going to take a lot of time. Once this is done, I'll be just sharing the notebook with you so that you can share this with all the participants.
Okay, sir. Okay.
Okay, sir. So I guess a lot of things that I wanted to show again, it went all just because of we had wasted a lot of time in the and execution, and a lot of errors also occurred. And if any of the party participants who want to contact me even after uh, this session, they can just clarify their doubts. I'll be sending my email ID, and as well as my contact number, so they can directly ping me on WhatsApp, and I'll be sharing I'll be sharing the necessary things regarding all the sessions that we had uh, taken. So shall we wind up, sir? Guru Prasad sir.
Yes, yes, sir. Thank you for
Okay.
your contribution and your insightful knowledge about how to work with Python and especially machine learning with Python. So our participant, I hope if they have any query, they will be asking. So I request all the participants if they have any query related to the topic explained, they can ask. I will be sharing the email ID and contact number of the resource person, so they can even contact them directly.
Yes, sir, sure. So I have already shared it in the chat box, and anyone who is interested, they can ping me, and we can just have a lot of things to be discussed. Okay, sir. Thanks a lot for inviting Innovatum for this FDP program, and we heartily thanks all the faculties, all the resource persons, and all the participants who are here. And I want these kind of things should be also in future. Thanks a lot, sir. Thank you very much.
Thank you, sir. So it was really a nice 5 day session. The time was a constant. Other because of limited number of hours and limited number of limited time. So still you have
Yeah.
covered a lot of topics. That was a really a good insight to all the participants, I hope. So thanks to all the participants for I can call it as active participation. So with this note, so we will end up today's session, and we will join tomorrow at sharply 9 o'clock. So I request all of you to join at 8:55 without fail. So please make sure that you are on time. So we are having some good resource person tomorrow. So who will be delivering their knowledge and sharing their knowledge at 9 o'clock sharply. Thank you one and all. Have a nice day ahead. With this, I am ending up the meeting. Thanks one and all.
Thank you, sir. I'll be sharing the once the epochs are done, I'll be sharing the notebook with the official email ID that you have sent, and from there the participant can take it.
Okay,
Thanks
Okay,
a
sir.
lot, sir.
Okay, sir. Okay.